Hi, in this video we are going to talk about hubs and switches. The differences, a bit of story, let's say. So to start from, we're going to start explaining just a bit how everything, let's say, started. So initially Ethernet worked over coaxial cable. Okay, so when a frame was sent, the frame was duplicated through all the different parts of the cable and arrived to all the connected devices. Eventually, if another device was sending another frame, this would cause a collision. Okay? So, how everything changed? First step was to use a twisted pair cable. So, this twisted pair cable offers an opportunity for structured cabling. Okay, with this structured cabling, we can introduce two types of devices, which is hub and switch. Okay, hubs and switch. So the idea of hubs and switches is that hub is somehow the same of a cable. It's a physical layer device that duplicates the information through all the ports that it has. Okay, while the switch could be thought as an extended version of the hub, as an enhanced version of the hub, which avoid collisions. So let's say how, thank you to this twisted pair cabling, we can use hubs and switches and how they work. So first of all, we have hubs. In this case, we have a hub with 4 hosts connected, and we have Ethernet over twisted pair in an structured way because we have 4 cables connected to the hub. In this case, if host A wants to send a frame, it goes to the hub and the hub takes the frame and duplicates it and sends it through all the ports. Eventually, if another host sends a frame as well, for example, in this case we have B and D sending a frame at the same time, this will cause a collision. So twisted pair with hub is very nice because you can easily build and extend networks, but you still have the problem of collisions. So what about switches, or also known as bridges? Sometimes you will also see the naming bridges, okay? So what's the difference? The difference of switches is that physically on the outside is very similar to a hub, and it behaves very similar at the very beginning. But the difference is that internally they have a forwarding table. Okay, so you can see in this case the example of the forwarding table. This forwarding table helps the switch to learn from the different MAC addresses arriving at the switch and reducing then the forwarding and avoiding collisions. So let's see with an example how this works. Initially, the table is empty, okay? So initially, the switch will behave as a hub. When a new frame arrives at the switch, the table creates an entry for it containing the source address, in this case, the Ethernet source MAC address, and the input port, which is the port from which the frame arrived. So for example, in this case, initially the table is empty and A is sending a frame. This frame has a destination C and a source A. So the first thing, when it arrives at the port number 1, the switch will add an entry for that with the source address, which is A, and port 1. Then it will check for the destination. The destination is C, and destination C is not in the table. As it is not in the table, it sends the frame through all ports. Eventually, this frame will be discarded by B and D, and only C will process it because it is the destination. So if C, for example, replies to this frame, it will send another frame with destination A and source C. This will arrive to the switch, and the switch will add another entry with source address C and the port 3 in this case. Once again, after adding the information for the entry, for the source address, it will check the destination address. In this case, destination address A exists. So in this case, the switch does not float the frame through all ports and only sends the frame through port 1, which is the one assigned to host A, as we can see in the table. Okay, so what happens when the table is completely populated, full of entries? So for example, in this case, A and D would be able to send traffic at the same time. In this case, A is sending traffic to C and D is sending traffic to B. They are sending the traffic at the same time and there would be no collision. So this is the main difference with a hub. We have traffic from different hosts and no collision. And even we even can have frames crossing together, okay? For example, if cables are full duplex, we can even send traffic from A to D without a collision. What is full duplex? Full duplex means that we have a twisted pair per each direction, okay? So we have 2 cables for one direction and 2 cables for the other. 2 links, let's say, like 4 in the same. You can check this, by the way, in your Ethernet cable, okay? If you take a look, you will see the 4 cables. So we send both frames and they are crossed and they don't have any collision either. We're going to provide an additional example with several switches. So what happens when we have several switches? In this case scenario, we have 2 switches and the tables are not empty. They already have some information. So this switch here has some information about MAC address P, and it says that MAC address 3 is associated with port 3, okay? And we have also information for MAC address E and the port 4. The same happens with this switch, which has this table already with 2 entries for B and for E. This is probably caused because previously maybe there was some communication between B and E, so they already have something learned from before. So now we are going to send an additional traffic. For example, imagine that we have A and A is going to be sending traffic to B. So the first thing that the switch has to do, as always, is to add address A to the incoming port, which is 1. Okay, so we add this entry. Afterwards, they take the destination. In this case, destination is port 3. Okay, so we send the traffic through port 3. As you can see, B is not directly connected to 3. Okay, but for a switch, we just need to know the outgoing port. And maybe it's not directly connected, but the following switch will forward it eventually to the destination. So in this case, when this frame arrives to the second switch, the first action is to learn the source address once again. So we learn address A, port 1, and then we check for destination B, which is port 2, and we send it to the host B. So in summary, a hub is like a physical, let's say, network repeater, does not avoid collisions, and the key advantage is that it allows a structured cable, okay? So the difference with a switch is a switch learns where devices are located, hence avoiding collisions, and it learns the network structure, and when substituting a hub, it improves the overall network performance in general. The question now is, what is the difference between a switch and a router? So for this question, I'm leaving you there just to think about it. Because a switch learns by default, it is empty at the beginning and learns, and it's capable of, let's say, forwarding traffic. So what is the advantage in comparison with a router, and what is the advantage of a router in comparison to a switch? Try to think about it. And once again, that's all. So thank you.